Hey guys, welcome to channel Sandhu. We are back with the part 2 of force and pressure, and if you want to see the part 1 of force and pressure, you can click on the information icon given above on the top right corner. In the first part, we had already discussed about what is force, what are the magnitude and direction of force, what is net force, and what are the different effects of force on an object. And in this part of video, we are going to discuss what is pressure and the pressure exerted by liquid and gases and what is atmospheric pressure. Firstly, we will discuss about pressure. What is pressure? Pressure is defined as the amount of force acting per unit area. We can denote pressure by P, force by F, and area by A. The mathematical expression for pressure is equal to force divided by area. That means P is equal to F by A. We can have an application example on pressure also. You can see two balloons on your screen. In first picture, we are trying to pierce a balloon with the sharp side of nail. And in the second picture, we can see we are trying to pierce the balloon with the another side of nail. In which case, it would be very easier to pierce the balloon. It would be in the first case. This is because when the area of contact is small, as in the case of sharp side of nail, all the forces is concentrated and applied on smaller area of the object. In the second case, the force is applied on a larger area, so it is more spread out, and this reduces the effect of force on the balloon per unit area. Here we have 4 subcases also. When force increases, the pressure would also increase. When force decreases, the pressure would decrease. When area decreases, the pressure would also increase. And in the case of area decreasing, the pressure would increase. As pressure is equal to force upon area, so that means pressure is directly proportional to force and inversely proportional to the area. We can further explain this by placing a brick in two different ways on a block of sponge. The same brick with the same weight affects the sponge in different ways. In second case, the same force acts on smaller area of contact, so it presses the sponge down to a larger extent. Hence, even when two forces are of same magnitude, we need another quantity to express this difference. This quantity is the force acting per unit area, and this is known as pressure. We can discuss here two cases. In first case, when force is same, the area would be more and the pressure would be less. And in second case, the force would also be same in this case, and the area would be less and the pressure would be more. This is the variation of pressure with force and area. Our next topic is pressure exerted by liquids. Fluids, that is liquid and gases, exert pressure as well. We can learn more about such pressure in fluids and its property using the example of water stored in a container. The first example is when pressure is applying at bottom of container. The property of this type of pressure would be pressure at the bottom of the container depends on the height of the column of the fluid above it. The pressure exerted at the base in second case is greater than as the height of the second column is greater than in case first, that is H1. In the first case, the height is H1, and in the second case, H2 is the height. So the pressure would be larger in case of H2 and smaller would be in case of H1. In this case, the pressure would be exerted at the bottom of the container. Our next example would be when pressure would be exerted at the walls of container instead of the bottom of container. The property of this type of pressure would be the fluids exert pressure on all walls of container. This pressure exerted by fluid is equal at the same depth. We can have an example of this one also. The streams of water falls at same distance from the container. If we fill the container up to heights, we had already made two holes on both sides of this container. If the holes are at same height, then the streams coming out of container would fall at same distance from the container. It indicates that equal pressure is exerted at both the holes that are made at the same heights. But instead of having the holes at same height, if we make holes at different heights, then we can see in second diagram the level of water is same, but the streams of water fall at different distance from different holes, because it would not have equal pressure at all the holes. It would have different pressure, so the streams would not fall at the same distance from the container. Now, as we have discussed earlier, that pressure is exerted by both liquid as well as the gases, and we have discussed earlier about liquids, and now we are going to discuss the pressure exerted by gases. Firstly, we would discuss that what is air. Air is also a fluid, and it consists of a mixture of many gases like carbon, nitrogen, hydrogen, oxygen. These all mixture of gases makes air. And when this mixture of gases makes an envelope of air around us, that is known as atmosphere. So we can say the atmosphere is the envelope of air around us. The mixture of gases, or we can say the air, has weight, and so it exerts a downward pressure owing to gravity. The pressure exerted downward due to the weight of air due to presence of gravity is known as atmospheric pressure. And as we have discussed earlier that pressure is the force exerted per unit area, and atmospheric pressure, it is the downward force exerted by a column of air on an area of 1 meter square. This pressure is quite strong. We do not feel this on our bodies. This is because we have the same atmospheric pressure inside our body. So the net force is 0. Now let's have a quick glance on the topics we have covered in this session. First one was pressure. Pressure is the total force acting per unit area, and we have illustrated this an example of balloon as well as the example of brick and sponge. The next topic was pressure exerted by liquids and gases. We have illustrated the pressure exerted by liquids by two examples. The first one was the container and the balloon, and the second example was about the container in which we have made two holes at same height, and in another example in which we had made holes at different heights. The last topic was about atmospheric pressure and the pressure exerted by gases. When air exerts a downward pressure owing to gravity, and this type of pressure is known as atmospheric pressure. As we can see, pressure was equal to force upon area. It is always exerted on unit area. In comparison, we can say the atmospheric pressure is always exerted on an area of 1 meter square. This pressure was quite strong as we have discussed, and that's why we do not feel this on our bodies. This is because we have the same atmospheric pressure inside our bodies, and because of this the net force becomes equals to 0. In this chapter we came across some important keywords, and let me explain what are those. The first one was net force. Net force is the combined effect of forces acting on a body from different direction, or we can say from same direction also. The second one is state of motion. The speed, the direction of motion of an object at any point of time is known as state of motion. And last one was pressure. Pressure is the total amount of force acting on per unit area. Before going ahead, here is an interesting question for you. Why camels have wider feet, and why they are preferred in desert rather than other animals? You can answer this question by commenting in the comment section. So here we have completed the chapter force and pressure, and if you like the video then please like, comment, share and subscribe the channel Sandhu.